Hello everyone, welcome to Earth Pulse Mining. We are excited to bring you our very first video, a presentation of our final year design project titled Engineering Design of a Zero Waste Gemstone Recovery Plant. Let's start the video with introducing you to the location that we considered for our design project. So basically this design is for a gem mine in Hidellana, Ratnapura, Sri Lanka. And talking about this gem mine, they have used underground mining method in the latter part of the 20th century and converted it to an open pit mine in 2012 with some semi-mechanized approach as well. And then talking about its gem gravel, the composition of the gem gravel, it has a higher content of clay and also fine gemstones with some minor amounts of golds, trace gold, coarser gemstones and also mineral sands according to the gem mine owner as well as according to our exposure at the mine. And also talking about the scale of this gem mine, it is known to be the largest and the deepest gem mine, open pit gem mine in Sri Lanka. And as you can see in the left hand side diagram, this gem mine is a placer deposit, basically a primary deposit. Now let's take a look at a video which basically shows you how the current process of this gem mine works. Our focus is mainly on the gem recovery process in this mine, and as you saw in the video, the gem recovery process is quite simple in the existing plant. And with the current process, once the gem is recovered, the slurry would be sent through a continuous settling tank process. So basically it has a continuous 10 settling tank procedure in order to settle the slurry and then get the quite cleaner water in the final tank for reusing process. So currently this is how the mine is carrying out its recovery process of the gemstones. And with that we identified a couple of operational challenges. Not only we, but also we got some challenges that the miners themselves are facing. So starting up, the biggest challenge out of all is the settling tank filling rapidly. So currently all the 10 settling tanks are quite filled with the slurry and a lot of overflowing is happening, and so that their mining processes, all their recovery processes have been shut down for a couple of weeks as well. So, and apart from that, something which rose from our end was losing of finer gemstones in the slurry. So this has never been identified as a challenge before, especially by the industry, but it could have been. So we suggest that our design could address this challenge as well. And also due to the scarcity of water here, because the proper water recycling is not happening with the currently available slurry treatment technique. So what we are trying is, so because of that, the industry, the miners in the field are trying to acquire the fresh water for their gem recovery, for their plant, for the gem gravel washing purposes. So our design is basically also to stop the usage of high fresh water consumption, to minimize the fresh water consumption. Though this mine is not using much of fresh water, all over the country in other gem mines they do use fresh water a lot. So our design is basically to minimize this as well. And apart from that, if we go into the economic and social impacts, so as I told you earlier, so the losing of gemstones can be an issue. So basically the revenue is lost through that. And apart from that, with the current available procedures in the gem recovery processes in the mines, there are some questionable issues with environmental pollutions and stuff. So we are trying to address them as well using our design. So simply our design objectives are first to maximize the gemstone recovery and also to recover the byproducts such as clay, sand, fine amounts of gold with finer gemstones as well that could lose. And apart from that, we are also trying to recover mineral sands and sands as well. And another objective of our design is to operate the gem recovery plant with a closed loop zero waste process, and then to reduce the environmental impact and improve the economical return of the mine. With the raised concerns, we got a couple of suggestions from the industry itself. So starting up with the optimization of the existing plants. So basically this was to have some periodical pattern in order to clean the slurry tanks. That was one of the suggestions we got from the industry itself. And another suggestion was to suggest a mechanical slurry separation, basically to improve the slurry treatment instead of focusing on the entire plant. So those two were a couple of suggestions that we got from the industry. So we identified that these suggestions would be kind of temporary solutions for these problems. So we're trying to make up a permanent solution in order to make a sustainable gem mine industry in the country and maybe finally in all of the world. And we also got a couple of suggestions from the industry to use trommels and vibrating screens for the plant, for the gem recovery plant, and also to introduce the flocculation for the slurry treatment, and to try to use the water as a controlled loop, to reuse the water as much as possible without using fresh water. So that was one of the concern we got. And also we were asked to look into the economy of do a financial feasible design so that the payback would be within 2 years. So these were quite this practical suggestions that we got from the industry. And let's move forward. Here we come to our proposed solution. So our solution starts with a hopper with a vibratory grizzly screen, and then once the gem gravel is input from there, it will be moved to the trommel 1, which is only taking particle sizes less than 50 millimeters here, and it will be introduced to a jig with a net size of 5 millimeters, and then to a jig which is of a net size of 2 millimeters, and then to the trommel 2, which is only taking in particles less than 10 millimeters. This is basically to recover finer golds in an efficient way. And next we are introducing the Hungarian sluice box with Hungarian ripples in order to recover the gold. And next we are moving forward to the trommel 3, which is only taking particles lesser than 1 millimeter here. And later we will be introducing the hydrocyclone. So the final parts from the hydrocyclone will be moving to a coagulant tank first. So in this coagulant tank we are introducing the coagulant, which is moringa powder, and that is basically to fulfill our requirement of going for something sustainable and biodegradable too in the meantime. And next we are moving forward to the flocculant tank, in which we are going to introduce the anionic PAM as the flocculant here, and then we are moving forward to the settling tank next, and the concentrated slurry would be pumped into the geotextile bags, which are made of honey, which are known to be the honey bags, and that will end the coarser, the finer section, and we are moving towards the coarser section, in which it starts with a settling tank, and the concentrated slurry will be transferred to the spiral. And here we are trying to obtain mineral sands and sands. So by recovering them, we are moving forward to the secondary settling tank, and finally we will be ending the process. So through the geotextile bags we will be getting clay cakes so that we could process it further for usage for the clay industry. That is the basic design. So this is the basic front elevation of our design, and next we will be taking you to the video, the animated video of our design.
Welcome to Earth Thrust Mining. In this video, we proudly present our zero-waste gem washing plant, a sustainable, continuous process designed to maximize gem recovery while minimizing environmental impact. The process begins as gem-bearing gravel is loaded into the vibrating grizzly screen through the hopper. With the help of water jets, the gravel is washed and mixed before being transferred to trommel 1, which separates particles smaller than 50 millimeters. The undersized material then passes through 2 jigs. The first jig with a 5 millimeter mesh and the second jig with a 2 millimeter mesh work together to ensure maximum gemstone recovery across different size fractions. Next, the flow continues to trommel 2, screening particles below 10 millimeters. Here, a Hungarian ripples sluice box is introduced to efficiently recover fine gold particles. The material then moves into trommel 3, which only allows particles smaller than 1 millimeter to pass. These fine particles are directed to the hydrocyclone for further classification and separation. The coarser fraction from the hydrocyclone is guided into the first settling tank, and the concentrated slurry is then pumped to a spiral separator, which recovers valuable mineral sands. The remaining slurry flows into a secondary settling tank where finer sediments settle and water is recovered for reuse. For the finer section, slurry enters the coagulant tank first, where moringa powder, a natural and eco-friendly coagulant, is added. Next, the slurry passes through the flocculant tank, which uses an anionic flocculant to bind remaining particles. The treated slurry is then pumped into geotextile honey bags for dewatering. And then, the clean water in this recycling process is recycled back into the system, maintaining a closed-loop process. Through this continuous integrated system, our zero-waste gem washing plant achieves high recovery, efficient water management, and minimal waste generation. At Earth Pulse Mining, we believe that innovation and sustainability go hand in hand, turning today's challenges into tomorrow's responsible mining solutions. Thank you for watching, and we hope this inspires more green mining innovations for the future.
We also carried out a mass balancing using MATLAB for the mainly for the process after the hydrocyclone, and it will need some more optimization as well. So more optimization is needed. So that will be the next stage of our design. So let's move forward. And this is basically regarding the overall solid recovery after the COSA and the finer sections. And again with the hydrocyclones. So now we are moving forward to the environmental and safety integration of our design. So as we are going with a closed loop water system and a biodegradable and usage of biodegradable coagulants, and using the dewatering of solid method, and also for the dewatering we are using honey bags, we are trying our best to get into the sustainable final segment with the environmental pillar, finally achieving the environmental pillar successfully as well. And talking about the safety integration for our design, we believe the workers in this plant should be using PPEs, personal protective equipment, and taking safety measures, since we are also using chemicals here with the flocculant usage, and also since this is going to be a mechanized mine, PPE is needed in our design plant. And talking about the performance and economic analysis, so according to the analysis that we carried out, we were able to find out that we could recover more than 95% of gem for sure, and also the water recycling is happening closer to 100%, and also in the earlier process, or else the existing process of these gem mines, they are currently using a lot of area for settling tanks, and we believe with our technique we could reduce the area of the settling tank to 80%, because in Ratnapura the land area is very, very important, because the gem gravel is quite consistently available, in a lot of the land area. And talking about the economic process or the financial feasibility we carried out, simply a financial feasibility we carried out of this plant, the capital cost would be around 166,000 USD with an annual operation and maintenance cost of 33,000 USD, and it would be paid back within 1.5 years. And it also got the value we got for our internal return rate is 70%, which is a great amount. And with that, let's move forward with some main features of our design. So one of the main feature is the multi-stage recovery, maximizing the gemstone capture, especially with the 2 jigs that we are going to propose here, and that we have already proposed here, and also the hydrocyclone that we use in order to separate the coarse and the finer section, and the flocculation technique that we used for finer particles combination. And also in this process, in the design that we used is mostly with gravity based layout. So this is simply reducing the energy cost as well. The energy usage is also minimal, which is supporting once again to the zero waste concept of our design. And this is also the maintenance of this design is not rocket science. It would be quite easy here. And let's come to the conclusion of our design now. So basically our design, which is zero waste gemstone recovery plant, is basically to integrate technology, sustainability and innovation together, and we are trying to redefine the future of gemstone recovery. And this is actually an effort of transforming the brilliance beneath Sri Lanka's soil into a beacon of sustainable engineering. And this is our team. So yeah, And if you do have any questions, make sure to drop it in this mail. And thank you so much for watching this video. Have a great day.